This video is the fourth video in the RoboWOKI group of videos for this assignment, and it's called RoboWOKI Selection. We've talked about sequence and iteration and indirection. We've talked about recursion. We've talked about all kinds of things. But something that you would hope a robot would be able to do, and one of the big concepts in computer programming and computer science is called selection. And selection basically means look at where you are, look at a value, look at something, and execute a program depending upon what you see in that value. So selection is do this if you see this, or do this if you don't see that. Well, that makes sense, right? We do that all the time in our daily lives as we navigate. If the traffic light is red, stop. When it turns green, go again. We're always aware of our environment, and our robot here can be also made aware of his environment. Let's stop and take a look here at this very simple world. It's just a really dumb little world of 4x4, and the robot can go any direction he wants, or she wants, or it wants to get back to the coin. I want to introduce a couple of ideas here in selection. The first selector I want to introduce is the exclamation point F selector. Now there are two kinds of selectors. There's the question mark selector and the exclamation point selector. A question mark selector executes a statement, a operation for the robot if the condition is true. An exclamation point operator executes a statement if the condition is false. So let's do a little simple. I'm going to create an indirection here. We'll create an indirection here called A, and I'm going to say exclamation point FRF dot. And I could also make that recursive, but I'm not going to. Star 5A. So let's take a look at the little script up here, and let's go character by character through what it's doing. Some of it you know, some of it you don't. So the first plus says, let's create an indirection. And the name of the indirection I'm going to call it A. So I'm going to create a new operation called A. Now look at what A does. It says exclamation point FR. Well, that says if I can't move forward, turn right. Exclamation point says if I can't, or if it's not. So if we cannot move F forward, turn right. After we turn right, sometimes go forward. So what's the robot going to do now that we've set, well, actually 5A isn't going to work. I'm going to want to say, let's change that to 20A. Let's change that to 20A. And so we're going to repeat A 20 times. So what's A going to do? It's going to go forward because the robot can go forward. Then it's going to go forward. Then it's going to go, oh wait, I can't go forward. Got to turn right, and then I go forward, and then it's going to go forward and forward, and then it's going to go, I can't go forward, I got to turn right, then it's going to go forward. So you're going to watch the robot go around the perimeter and over to the coin. Not the most efficient way, but you can see how this program will now solve all kinds of problems. I could change the size of the world, I could add obstacles, I could do all kinds of things. And as long as it's always a combination of turning right and moving forward, the robot this one program now can do lots of different worlds, can solve lots of different worlds. Let's run this and see what happens. So I come here and go run code, and you can see that we execute A and he moves forward. We execute A, it checks, he moves forward. We execute A, it checks, turns right, then moves forward. And here it goes. It's going to check. Oh, I can't move forward. Got to turn right, move forward. And so it solved the puzzle in 11 moves. Now, it could have been done quicker than that, but you can get the idea here of the selection. And the selection there of not R or not F. If I cannot move forward, turn right. Now, I can also say if I can move forward, do something. So I could have done question mark F instead of the not F. I could do question mark B or not B to check if I can move backward. I can do question mark R or exclamation point R to check whether I can move right, or question mark L or exclamation point L to see if I can move left. I can also do a question mark C or exclamation point C to check if I'm in a square with a coin in it. Now that would really only work if you've got a program with multiple coins and you want to go to the coin and do something and go to another coin and do something. But you can see here how we check that condition at every square. We go to the first, check the condition, move on, okay, check the condition, okay, move on, check the condition, move on, oh well, we got turn right, now then we can then move on and check the, so you can see that this condition, this selection is being checked every single time the robot goes and calls A. Kind of interesting, isn't it? It's kind of fun. So let's take a look at a different type of condition or selection that RoboWOKI lets us do. If we click on the little box here that says show addresses, you see that now there's a number on every cell in the world. Every box in the world has a number. So we can also use the numbers to make choices. We can use the numbers to make choices. I'm going to go kind of crazy here and write a script. I'm going to call it W for weird. I'm going to say, okay, robot, if you're at cell 2, turn right. If you're, let's keep that uppercase. Even though upper and lowercase don't matter, you can do things in upper and lowercase, and RoboWOKI doesn't care. So I'm then going to say at cell 6, turn left. At cell 4, turn left. Always go forward, recurse back to W, and then execute W. Let's see what happens. So robot's going to go to 2. Then he's going to turn left. He's going to 6. He's going to turn left again. And he's going to walk off the edge of the screen, and that didn't work. So I made a mistake in my program here. So you can see that I say at 2 turn right, at 6 I want it to turn right, and then at 4 I want it to turn left. So now let's run that code again and see if it works this time. So at 2 turn right, at 6 turn right, and at 4 turn left. Yay! Now, that wasn't the most efficient way to solve the problem, but let's look at our code here, because our code says create the indirection W. If we're at 2, turn right. If we're at 6, turn right. If we're at 4, turn left. Always move forward and then recurse back into W to repeat it forever. So you can see here how by using the addresses and by using selection, question mark selection is, are we at that square? Exclamation point selection, are we not at that square when we use the number? So you can use the selection in your indirection, in a loop, in all kinds of, in an iteration to make the robot do all kinds of groovy, fun stuff. So that's an introduction to selection. There are a couple of other introductions to a couple of other examples in the handout that you'll find attached to this assignment in Blackboard. If there are any questions, you can contact me at jrenault@shawnee.edu. This presentation was copyright 2021 by James M. Renault, PhD. All rights are reserved. And I'd like to say thank you for watching, and I hope you have a great semester.